Okay, so hello and welcome back. So in this video in this basically playlist, we will talk about class 10, chapter 5. So this is basically, this whole playlist is dedicated to NCERT mathematics, class 10, chapter 5, arithmetic progressions. Arithmetic progressions. So there is really not, there is a couple of things here to learn, and then after that we can talk about there is another chapter about sequences and series. But first I wanted to talk about this chapter, and then we will go back to sequences and series and talk a little bit about those things. So basically, as an introduction, we have basically, you have observed that in nature many things follow a certain pattern, such as the petals of a sunflower, the holes of a honeycomb, or the grains on a maize cob, or the spirals on a pineapple, and a pine cone, etc. So there is these patterns, of course, in nature everywhere. And so we now look for some patterns which occur in our day-to-day life, such as the following. For example, Rina applied for a job and got selected, right? She's been offered a job with a starting monthly salary of 8,000 rupees, with an annual increment of 500 rupees in her salary. Her salary in rupees for the first, second, third, and so on years will be respectively as follows. So basically what happens is that, for example, in this situation, Rina basically applied for a job. She got selected. She has been offered the job on these conditions, that basically a starting monthly salary of starting monthly salary of basically 8,000 rupees, right? And with an annual increment of 500 rupees in her salary, with an annual increment of 500 rupees in the salary, of course. So which means that her salary in rupees in the first year, so her salary in rupees for the first, second, third, etc. And so let me write it this way: third and basically third and fourth, and so on and so forth years would be as follows. So in the first year she will get, that is the starting salary, which is 8,000 rupees. Then that will be incremented by 500 rupees, which means that she'll get 8,500 rupees, and then she'll get 9,000 rupees, and so on and so forth, right? So you can see a pattern over here, and the pattern is that basically these numbers, whatever they might represent. Now in this particular case, they represent the salary, Rina's salary, basically, from the first year to the second to the third and so on years. And they basically they start with 8,000, and then you add 500 to that, you add 500 to that, and so on and so forth until you get to the nth year, right? So you can call it the second year, the first year, the second year, the third year, and so on and so forth. And so you can logically go all the way up to the nth year, meaning that based on this pattern, it should be possible actually to find out what is her salary in the 22nd year, for example, or in the 25th year, or in the 30th year, without actually writing writing out the numbers. There must be some way to be able to find out what is the salary in any number of years, right? And that's basically what we want to do in this chapter. We want to learn how to deal with these kinds of numbers, or these kinds of patterns, where you can find a rule or something. For example, the rule over here is that basically your numbers start with an amount, and that amount is incremented or decremented by an amount every time you get to the next term and to the next term, right? And now what we want to do is that we want to learn how to basically calculate, for example, the nth term, for example, in these numbers. Of course, we will get there in just a few videos. Now, for example, and as another example, we can say that the lengths of the rungs of a ladder decrease uniformly by 2 centimeters from bottom to top, and the bottom rung is 45 centimeters. So if the bottom rung, if you think of a ladder like this, and for example, let's say that this is the ladder and these are the rungs of the ladder. So you have basically some situation like this. Now, of course, this is not exact. I mean, that the distances are not the same, but you can imagine that this bottom rung is 45 centimeters, and every time that you go to the next rung, 2 centimeters is subtracted from the previous rung, meaning that you get 43 centimeters, 41 centimeters, 39 centimeters, and so on and so forth. Which means that for the lengths of these rungs from the bottom to the top, you get 45 centimeters, 43, actually the centimeter part is not really required in the numbers, 45 and 43 and 41 and 39 and so on and so forth. So you can see that in these numbers, this number is the same thing as the previous number minus 2. This number is basically the previous number minus 2. This number is the previous number minus 2. Or you can say that if you add 2 to this number, you'll get the previous number, something like that, right? So there is a rule over here that you can find as well, right? Now the next thing that we have here is the next example is essentially is in a savings scheme, the amount becomes 5/4 times of itself after every 3 years. So you have a savings scheme. We are talking about the savings scheme, and the amount becomes 5/4 times itself every 3 years. Meaning that, for example, and the maturity amount of an investment of 8,000 rupees after 3, 6, 9, and 12 years will be respectively. So then you can call the maturity amount, the maturity, these are the terms that they use in finance probably, the maturity amount of, in rupees basically, in rupees, of an investment of 8,000 rupees, 8,000 rupees in every 3 years, so 36, 9, 12, and so on and so forth years would therefore be, so you start with 8,000 rupees, and after 3 years this amount will be 5/4 times itself, meaning that 8,000 rupees times 5/4, that's the same thing as basically divide by 4, you get 2,000. 2,000 times 5 is equal to 10,000. 10,000. And then you have basically so after 3 years you will get the maturity amount becomes 10,000. After basically this amount, after another 3 years, this becomes 10,000. 10,000 times 5/4, which is equal to 2,500. 2,500 times 5 is equal to 10,000. 12,500 becomes 12,500, right? And then you have basically again the same amount, 12,500 after 3 years becomes 12,500 times 5/4, which is the same thing as basically 125 divided by 5 divided by times 5 divided by 4 would be equal to 125 divided by times 5 would be 25, 2, 10, 12, 1, 600, 625, 0, 0, and 625 divided by 4 is not actually, you have to write it as 500 divided by 4. That would be equal to 1 times 4 is equal to 4, 2, 2, so 5 times 4 is equal to 22, 5 times 4 times 5 is equal to 20, 5, 0, 4 times basically 4 times no, there is a 6 over here. There is a 6 over here, and so you get basically you will get 6 times 4 is equal to 24, and then 1, and then you have a 0. 2 times 4 is equal to 8, 2, 5 times 4 is equal to 20, right? So that's 15,625. That's 15,625, right? And then after that you have basically again this amount becomes basically 5/4 times itself, meaning that you have 15,625 times 5/4. And then if you do this calculation, you will get something like, for example, let me do the calculation using calculator. You will get something like 15,625 times 5 and divide that by 4. You will get 19,531.25. You will get basically 19,531.25, and so on and so forth. So that is basically, again, you can see that basically there is a rule that you can find in these numbers, right? Meaning that now this time the numbers are not, you cannot say that, for example, the number is being, something is added or subtracted to the number, but essentially some constant is being multiplied by each number to get to the next number and to the next number and so on and so forth. So again, there is some rule over here that you can observe, right? Now, there is, or for example, as another interesting thing, you can say, you can count the number of unit squares in with the number of unit squares in squares with sides 1, 2, 3, and so on and so forth. Meaning that if you have a simple square over here, suppose that you have this square, and suppose that the side is 1 unit. Now suppose that I make the side 2 units. I make the side 2 units. And suppose that I make the side, for example, 1, 2, 3 units. 1, 2, 3 units. And so on and so forth. So this is basically 1 unit, this is 2 units, this is 3 units. And these are cubes, of course. So this is 3 units, this is 2 units, this is 1 unit. Now the number of unit squares in each of these squares is basically, if that's the side length is 1 unit, here the side length is equal to 1 unit, and the number of unit squares, in this case is basically as follows. So you can say that when the side length is 1, the number of unit squares is 1. When the side length is 2, the number of unit squares that you can find there is basically 4. When the side length is 3 units, this is in units. When the side length is 3 units, then the number of unit squares that you can find is 9 squares. That means that basically, and so on and so forth, and so on and so forth, and so on and so forth. This basically means that the side length is always, or the number of unit squares, the number of unit squares is equal to basically always equal to the side length is equal to the side length squared. Whenever you square the side length, you get the number of unit squares that you can find in the main square. Meaning that over here you can see that basically 1 squared is equal to 1. 1 squared is equal to 1. Over here you can see that 2 squared is equal to 4. And over here you can see that 3 squared is equal to 9, and so on and so forth. There is a pattern over here that you can observe. And so basically we can write these numbers as basically as 1 squared, 2 squared, 3 squared, and so on and so forth. So I can write 1, 4, 9, for example, 16, 25, and so on and so forth. And then you can write this as 1 squared. You can write this as 2 squared. You can write this as 3 squared, and 4 squared, and 5 squared, and so on and so forth. Right? So each time that you want to get to the next term, basically you have to basically, you could say that, for example, you have to increase the base by 1, and then you'll get to the next term over here. So that's also something that we can appreciate here. I mean that's basically some pattern that we can appreciate there. As another example, we can mention the example of basically a money box, which is a cute name for saving. Okay, so the next basically example that we have here is, for example, Shakila puts 100 rupees into her daughter's money box when she was when she was 1 year old, and increased the amount by 50 rupees every year. So when she was 1 year old, when the daughter was, for example, when the daughter was 1 year old, the amount of money was 100 rupees. The amount of money was 100 rupees. And then it was increased. It was increased every year by basically 50 rupees. Of course, there is no reason to do that, because at the end of even after 20 years, you would not end up with much money. But as an example, as an example, then you would, when the daughter was 1 year old, then she has, for example, 100 rupees. The next year, 150, 200, for example, 250, and so on and so forth, right? There is another example about a bunch of rabbits that I never actually understood. I'm not going to repeat that example here. That example is too complicated, and I'm not going to, and I couldn't find any way to think about it logically, so I'm not going to repeat that. So, but basically in all of these examples, we observe some patterns. For example, over here you can see that every number is added 50 to each number to get the next number, and so on and so forth. So you either basically add a number to each term to get to the next term, or subtract a fixed number from the previous term to get to the next term, or each term is multiplied by a number to get to the next term, or so, and so on and so forth. So now one of these patterns in which basically you have in which basically each term is added, or a fixed term is added to each term to get to the next term. Either that fixed term is negative, is a negative number, or a positive number, that doesn't really matter. But suppose that, for example, you have 1, 2, 3, 4, 5, and so on and so forth, or 100, 150, 200, 250, and so on and so forth. So in this case, for example, you're adding 1 to each term to the next term. In this case, you're adding 50 to each term to get to the next term, and so on and so forth. So this is one of the patterns that we saw in these. This is one of the patterns that we saw here. And in this chapter, we are going to talk about different properties of such patterns, which are by the way called arithmetic progressions. Arithmetic progressions. So we are going to talk about arithmetic progressions. So this was just an introduction, and so in the next video we will start talking actually about arithmetic progressions. I'll see you in the next video, and thank you.